This is a short video that will help you answer many problems on assignment 5-2. In a typical problem, you are shown drawings of two molecules. Your task is to determine if these molecules are identical or different, and if they are different, say how they are related. If they are isomers, answer the question, what type of isomers are they? The key to resolving this type of problem is to compare the chirality centers of the two molecules. Assuming the two molecules have the same structural formula, there are three possibilities. 1. All chirality centers in the two molecules have the same configuration. If so, the two molecules are identical. 2. One or more of the chirality centers of the different molecules are different, but they are not all different. If so, the two molecules will be diastereomers. 3. All of the chirality centers of the molecules are different. If so, the two molecules are enantiomers. So here's a problem. Let's compare these two molecules. How are they related? Are they identical? If they're not identical, are they isomers? If so, what type of isomers are they? Well, when we compare them, we see they have the same structural formula. They each have three chirality centers. Let's now compare these chirality centers. We start with the first, and they're the same. Two methyl groups are there's a methyl group on each pointing up. The second chirality center has a methyl group pointing down. The third chirality center and the first one has a methyl group up, and in the second molecule it points down. So what we have is three chirality centers in each molecule, two of which are the same and the third is different. That would make these diastereomers. Here's another problem. Comparing these two molecules. They certainly have the same structural formula. Each has 3 chirality centers. Let's compare the chirality centers. Alright, let's start with the top. We go 1, 2, and then in the second molecule 1, 2. Each chirality center in those two are different. Then we go to the last chirality center. The first molecule, that one's down, and in the second molecule, that one's up. So as you compare, we can see that in the two molecules, all of the corresponding chirality centers are different. That would make these two molecules enantiomers. In the third problem, let's compare these. Now this may initially they may look different. Let's check and see if they have the same things attached, if they have the same structural formula. The first one has a hydroxyl, and 2 carbons over has a methyl, and then the next carbon has an ethyl. In the second molecule, have a hydroxyl, 2 carbons over a methyl, and then 1 carbon over ethyl. So they have the same structural formula. And so let's compare. If we start with the first molecule, we have the OH pointing up. In the second molecule, although the molecule looks like it's been rotated, the OH is pointing up. Then in the first molecule, we count 2 carbons over. We have a methyl group pointing down. In the second molecule, 2 carbons over, we have a methyl group pointing down. So far, those are all identical. Then in the first molecule, when we move 1 carbon over, we have an ethyl group pointing up. And in our second molecule, starting with that methyl group, we go 1 over and we have an ethyl group pointing up. So you can see that these two molecules, they have the same structural formulas. Their chirality centers are all identical. Everything's in the same place. These molecules are identical. This concludes the video. Thank you for watching.